Hello and welcome back to section 1.3. We got about halfway through it. We were looking at different sampling methods. So now the second half of this section just gets into other types of data collection and where they can be applied. So basics of collecting data. Statistical methods are driven by the data that we collect. We typically obtain data from two distinct sources: observational studies and experiments. So observational studies by definition are when you are observing and measuring specific characteristics without attempting to modify the individuals being studied. So again, very important that you're not modifying things. Whereas with an experiment, now we're applying some treatment and then proceeding to observe its effects on the individuals. The individuals in experiments are called experimental units, and they are often called subjects when they are people. So we have a couple of examples here, but then I want to do some examples from the textbook as well. So an example of ice cream and drownings. Observational study: observe past data to conclude that ice cream causes drownings, based on data showing that increases in ice cream sales are associated with increases in drownings. The mistake is to miss the lurking variable of temperature and the failure to see that as the temperature increases, ice cream sales increase and drownings increase because more people swim. So this kind of gets into another area that we're not specifically talking about in too much detail, but it's looking at causation versus correlation. So just because two things are linked doesn't mean that one thing causes the other thing to happen. So you gotta be really careful about that. So causation versus correlation. So let's take a look at the experimental side of this. So if we wanted to do an experiment related to this, we could conduct an experiment with one group treated with ice cream while another group gets no ice cream. We would see that the rate of drowning victims is about the same in both groups, so ice cream consumption has no effect on drownings. So here the experiment is clearly better than the observational study. So now looking at your notes, it looks like we got example 28 on page 34. So let's cut over to the textbook. And if we turn to page 34, give it a second to load. And let's zoom it in a little bit. There we go. So now if we scroll down to 28. So it says medications. The Pharmaceutical Research and Manufacturers of America wants information about the consumption of various medications. An independent researcher conducts a survey by mailing 10,000 questionnaires to randomly selected adults in the United States, and she receives 152 responses. Well, the first question you probably are wondering is, what's the question? So in order to see that, let's go back page, and let's go down to the bottom. Okay, so here we go. In exercises 21 to 28, determine whether the study is an experiment or an observational study, and then identify a major problem with the study. Okay, so let's go back and look at it again. So pharmaceutical researchers want information about the consumption of various medications. An independent researcher conducts a survey by mailing 10,000 questionnaires to randomly selected adults in the United States, and she receives 152 responses. So first we have to determine, is it an experiment or is it an observational study? So are they applying some treatment? Are they affecting their subjects at all? Well, probably not. They're mailing out a survey or a questionnaire. So it's not really, influencing them one way or the other. They're just answering questions. So they're not applying some treatment of some sort. So there's the rationale for it being an observational study. So now the other part of the question was, what's wrong with this? So look at the question again. They send out by mail 10,000 questionnaires to randomly selected adults. Random's good. And she receives 152 responses. Well, there's a couple problems. First of all, mailing, although it's pretty widespread and you can hit pretty much everybody. What's the problem with that? You're not necessarily getting every possible person in the United States involved in that because not everybody has a mailing address. So there's a potential flaw with that. Even though it's pretty widespread, most everybody has a mailing address, not everybody does. So you are excluding some people. What about the response rate? Is that good? Well, 152 out of 10,000, that's a pretty small response rate, 1.52%. So that's not very good. So that's the other problem. So what else could you say about that response rate and responses in general? Well, did you have to respond? Obviously not. So it was voluntary. Yeah, it's voluntary. So that means that's also a potential problem. They have a vested interest in completing that questionnaire and submitting it. So it was voluntary, it was mailed, the response rate was terrible. So there's 3 big problems with that whole thing. So that's kind of the idea with that. All right, so let's go back to the PowerPoint for a second. And so we're going to look at experiments in more detail, but first we're going to break down the different types of observational studies. So we got 3 of them. We got cross-sectional. So data are observed, measured, and collected at one point in time, not over a period of time. Usually that's now. Retrospective or case control study, data are collected from a past time period going back in time through an examination of records, interviews, and so on. So retro, when you think of retro, you think past. That's what's going on here. Prospective or longitudinal or cohort study, data are collected in the future from groups sharing common factors called cohorts. So we got present, past, and future. All right, so let's go back to the textbook again, and let's take a look at number 29, which says, indicate whether the observational study is cross-sectional, retro, or prospective. So nurses' health study. Phase 2 of the nurses' health study was started in 1989 with 116,000 female registered nurses. Study is ongoing. So what are you thinking about that one? Well, first part of it says it was started in 1989, which is definitely in the past. So your gut right off the bat says it's retrospective, right? Retro is past, so retrospective. But what's the problem with that? What's the last sentence telling you? Study's ongoing. So that means it's going on into the future. So this is actually a prospective study. Even though it was started back in 89, it's ongoing. That last sentence is what kills it. So because it's ongoing, that means it's still going on into the future. So be careful. They like to try to trick you with these questions. So really take your time to think about it. Number 31 was also highlighted. Marijuana study. Researchers from the National Institutes of Health want to determine the current rates of marijuana consumption among adults living in the United States that have legalized the use of marijuana. They conduct a survey of 500 adults in those states. So, what's the magic word in that whole mess that gives it all away? Current. It wants to determine the current rates of marijuana consumption. So current means right now, which means it's cross-sectional. So it's got to be a cross-sectional study because it's current. All right, so that's kind of the idea with those questions. So let's flip back to the slides. And we got just a little bit left here. So now we can turn to experiments and looking at different elements of experiments. So replication is one of the first things. It's the repetition of an experiment on more than one individual. Good use of replication requires large sample sizes that are large enough so that we can see the effects of treatments. Again, we don't like small samples with anything. If you have too small a sample, you're really not going to get a broad spectrum of results or repeating results that shows you that you actually have something worthwhile to share. So replication is definitely a good aspect of design for experiments. Next, we got blinding. So blinding is a technique in which the subject doesn't know whether he or she is receiving a treatment or a placebo. Blinding is a way to get around the placebo effect, which occurs when an untreated subject reports an improvement in symptoms. So I'm sure most of you have heard of placebos. So placebos just means it's a sugar pill or something like that that makes you think something's going on, but nothing's going on. So now, blinding on the surface seems like a really good idea, but sometimes experimenters give it away. They have little facial cues that the subjects pick up on and say, oh, I know I'm getting the placebo, or oh, I know I'm getting the medicine. So that kind of gives it away. But we can fix that too if we double blind. So blinding occurs at two levels. The subject doesn't know whether he or she is receiving the treatment or a placebo, sorry about that. And two, the experimenter does not know whether he or she is administering the treatment or the placebo. So now, if the experimenter doesn't know, and then the patient doesn't know, or the subject doesn't know, now you're really going to get some good results from that. So next we got randomization. So randomization is used when subjects are assigned to different groups through a process of random selection. Logic is to use chance as a way to create two groups that are similar. So again, we've talked random galore. So random is always something we want to do so that way there's no kind of bias or anything like that with the experiment. So the gold standard randomization with placebo/treatment groups is sometimes called the gold standard because it is so effective. A placebo such as a sugar pill has no medicinal value or medicinal effect, which we just said. Okay, so even though we try to do those things, there's still problems that occur. So confounding occurs in an experiment when the experimenter is not able to distinguish between the effects of different factors. Try to plan the experiment so that confounding does not occur. Okay, so again, we want to always try to avoid mistakes and errors and things like that. So what are some ways we can do that? So we got the completely randomized experimental design assigns subjects to different treatment groups through a process of random selection. Again, random, random, random. Randomized block design is kind of a subset of that. A block is a group of subjects that are similar, but blocks differ in ways that might affect the outcome of the experiment. There's a really common randomized block design that I'm sure you know about if you think about it a little bit. What are ways that subjects could be separated into blocks or groups that make sense for some kind of experiment with medicine and things like that? How about gender? That would be one way to do it. So males and females obviously react differently to different types of medicine. So that's a randomized block design that you could use. Okay, so let's go on to the next. Matched pairs. Compare two treatment groups by using subjects matched in pairs that are somehow related or have similar characteristics. So what's a matched pairs design? Somehow related or have similar characteristics. What about identical characteristics? Yeah, twins. Twins is going to be the way that works. So if you have identical twins, especially identical twins that have exactly the same genetic makeup and whatnot, so if you can test on one and then you test on the other with placebos, and then you can see the effects really heartily of what's going on. So that would be an example for matched pairs. Rigorously controlled design carefully assign subjects to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. This one's a little bit harder to wrap an example around. I would say that you could still do sort of a gender-based design, but you're really kind of, boiling it down even more. So maybe redheads or something like that. Some other type of either genetic or physical relationship that you have, and then you're looking at how it affects each of those subjects. So again, I wouldn't get too worried about it. If I'm having, trouble trying to give a good example, that means I'm probably not going to worry too much about it. So don't stress over that one. Okay, so that's kind of the sense. So those descriptions should help you with the homework as well. So the last part of this does get into the errors side of it. So if we looked at errors, so no matter how well you plan and execute the sample collection process, there's likely to be some error in the results. So we got a few different error types that we could have. A sampling error or a random sampling error occurs when the sample has been selected with a random method, but there's a discrepancy between a sample result and the true population result, such as error results from chance sample fluctuations. So really what this boils down to is sample size. If you have too small of a sample, you might get unlucky and have that small sample all show the same thing. It's like, oh, well, their hair fell out early or something like that. And it's just bad luck because you had a small sample. But if you have a large enough sample, then you would see that that's not necessarily the case. So generally a small sample. So even though the randomness is there, you just were unlucky because the sample size was too small. Okay, so the other ones, we got non-sampling errors. The result of human error includes such factors as wrong data entries, computing errors, questions with biased wording, false data provided by respondents, forming biased conclusions. So again, all kinds of like voluntary responses, and you can have a small sample size in there as well. But what if I were taking the heights of everybody in the class and I miswrote people's heights? Well, that's going to throw things off from what it should be. So that's kind of the idea with that. So that's more of a human error issue. A non-random sampling error is a result of using a sampling method that is not random, such as using a convenient sample or a voluntary response sample. So again, non-random in there is the key. So again, voluntary response sample is one of the big ones we like to avoid. So, and that should be it. So now you can jump into the homework assignment for 1.3, and hopefully you can get through it without too many problems. But if you do, definitely reach out. So I will see you in the next videos.